Okay, folks, we are ready to begin Volume 2 of Harry Potter and the Secret of Economics, which I hope to make a ton of money from. Let me start by giving you a reprise of what we did, or where we ended up with Ricardo's argument, because I want to pursue that, and hopefully I can get past it and get on to other aspects. But this is a difficult and subtle series of arguments in Ricardo, and so it's very important that we get it right rather than kind of hope that we got the point. Okay, so all the more so because it's going to be on the midterm, so you do want to know how to get it right. First point, we're talking about natural prices, and natural prices are those prices which are the centers of gravity of market prices. We discussed that. Does anybody have any questions about that concept of gravitation rather than equilibrium? Okay? Great. Second is that Ricardo approaches this problem in a series of steps. And we talked about the first step, which last time was an example, an elaboration of Smith's argument that we can start by first positing a hypothetical society. Smith makes it seem like it existed in the past. He calls it root and early state. But Ricardo points out it doesn't actually exist. It's an analytical stage. And what we want to do is to say that capitalism consists of two moments: the existence of a class division of value added, if you want, in the existence of classes itself, and of competition. Right? So those are the two things that they want to focus on. So he begins by first focusing on competition without yet introducing class. That's, again, scientifically the appropriate way, because then you can show by introducing something what difference it makes. Everybody with me here? Okay. So we start with what could be called simple commodity production, or commodity production alone, in which producers are assumed to own their own machinery and raw materials, the means of production, their own means of production. So it's not true that we're abstracting from machinery and raw materials. What we're abstracting from at the moment is a separate set of owners of these things, which is, in other words, abstracting from a class division of the ownership of the means of production, to put it in more familiar terms. And he assumes that in this case, if there is competition, then producers will migrate to the sectors where they get the greatest net return, value added, on their effort. Everybody understand that? Value added is a simple concept. If I have two sets of people here, the beaver producers and the deer hunters, the beaver hunters will get a certain income per hour of labor, or an income per beaver, which comes to the same thing. And that is the difference between their price and the cost of their inputs. It's their value added, because they don't have to share it with anyone else. They get the whole value added. So if the value added per product or per hour of labor is higher in beaver than deer, then people are going to drift. There's going to be a diffusion towards beaver production. And in that case, there's going to be an increase in the supply of beaver production relative to the demand, because the diffusion will be accelerated until that tipping point comes reached. And then the price of beaver will come down, thereby lowering the income, value added per hour of labor in this activity as opposed to there. And this process, Smith says, if we have competition and we have the mobility of producers and we have means of production but no class, then the result will be an equalization of incomes per hour of labor. This is an analytical thing. And in that case, we can show easily that prices must be proportional to direct and indirect labor time. And we do it, and I'm going to do it here, but just to think about this intuitively. If I get an equal income per hour in every product, then I get an equal income per hour also in the production of the materials and the machinery, so that all my costs and my revenue are going to be proportional to the income per hour. I can say immediately that the price will be such that it gives me an equal income per hour in every hour of labor from competition, then the price will be proportional to the direct and indirect labor time, because the income per hour is a number. So my income will be proportional to the amount of living labor, but the cost of the raw materials and machinery will be a proportion to the amount of labor in that, and the labor in their raw materials and machinery and so on. So if we add up all the labor times, the price will be proportional to that by this term, the equal income per hour, whatever this number is. We said $10 an hour, right? So price will be $10 an hour times the amount of direct and indirect labor time. It follows that relative price will be proportional to relative labor time. This is a simple labor theory of value, but not meant to be a desirable state. It's a simple labor theory of relative price, which is what the term value means in the classical tradition before Marx. Everybody with me here? So we did this last time, and just to run you through the example without getting into too much detail, I forgot that I bought a laser pointer at the beginning of the semester, so I forgot it. But anyway, hypothetical situation, 5 hours of labor plus 1 trap. And then that trap with 15 hours of labor produces 1 beaver. 7 hours of labor produce bows and arrows. 3 hours of bow and arrow hunting produces 1 deer. Then we know how much the labor time is in a beaver, direct and indirect. It's 15 hours of living labor plus the 5 hours required to produce a trap. That's 20. How much labor time in a deer? It's 3 hours of hunting plus 7 hours of bows and arrows. That's 10. But let's suppose that the price was such that beaver sold for $2.20 a beaver and deer sold for $90. So these are just arbitrary prices. But the point is that at these prices, incomes per hour would be unequal. And if incomes are unequal, then the price, the higher income per hour in beaver than deer, this is just an arbitrary price. But the point is that you can see from the logic of it, any price that gives you a difference will be changed. Change because more people will come into beaver production, the price will come down. Fewer people will be in deer production, relatively fewer, so the price will come up. And we know that the answer is that you will end up with a new set of prices, and that new set of prices will be such that, where did they go? I think it's further down. Yeah, no, it's okay, they're there, okay. So the new set of prices will be 200 in beaver and 100 in deer, and that'll give an income per hour of 200 over 20, that's 10, 100 over 10, that's 10, and therefore the ratio of price of beaver to deer, which gives you the equalization of incomes per hour, or value added per hour if you prefer, will be 200 to 100, which is 2, and that, as you can see, logically will be the same as a proportion of direct and indirect labor time in one sector to the other. So this is the base point, the point being that under these conditions, the prices are proportional to labor time. Now, one might reasonably ask, well, why start with this? We're certainly not going to end with this, and the answer is we want to build into the logic of the argument the other elements one step at a time. If you want to think of an analogy, it is like Newton beginning with the law of gravity, but abstracting from the fluid through which things move when you test the law of gravity. You know, do you remember your physics classes? Well, my physics class, we went up to the top of a building and dropped things until we could show that they dropped at the same rate. But obviously that doesn't work for things like paper, or doesn't work for things that have a big shape because the friction from the air will affect their speed. Does that mean the law of gravity is overthrown? Well, Newton tells us already it's not, because if we put them in a vacuum, then a feather falls as fast as a BB shot, because they don't depend. Some of you look surprised, so I haven't taken physics in a while. And not dependent at all on the shape or the weight. And so what the difference in their trajectories depend on is the fact that they're falling through a fluid. Air is a fluid. And that fluid affects the rate of fall, but it's a modification of the original argument. It doesn't invalidate it. So the classicals are approaching it in exactly that scientific manner. First identifying the key element, which is competition and equalization of incomes, and then they're going to add things at a time. So the next step, any questions about this? So the next step is to add in class. And Smith says, look, suppose that instead of this value added of $10 an hour here and $10 an hour here going entirely to the producers, suppose that 30% went to capital and 30% and 70% went to labor in every sector. The division was the same. Well, obviously then the total is still going to be unchanged by that, and one can show that easily formally. But you can see intuitively that everybody divides their value added in the same proportion. The profit-wage ratio is the same in every sector. Then prices will continue to be the same as they were before. And so the principle set up in the first step is not altered by the existence of class per se. So that establishes a very important point, that it's not the existence of a class division of labor, that of a division of value added that makes prices deviate from relative labor times, but something else. Everybody with me here? Any doubts? Questions? Okay, so let's get to the something else. Smith himself says, well, okay, if every sector has $7 for labor and $3 for capital, right? Then the profit rates will not be equal unless capital is proportional to labor or proportional to the wage bill. Let's suppose wages are equalized. So every worker gets $7 an hour now. But the other 3 now is going to capital. Well, if capital is proportional to labor in every sector, then 3 will give you the same ratio in sector 1 and in sector 2. You can easily make up numbers, and in fact, we're going to do that here. If you go to that second sheet, to page 3 it is. The page numbers didn't print. Yeah. No. Yeah. Wait. Yeah. Oh no. Here. Right up at the top. Suppose I divide the value added into 4 and 6. Then there's no change in the total value added. The division is the same in every sector, and the prices are not changed. Now suppose we consider the fact that there's a capital labor ratio of $60 an hour in the first sector and $60 an hour in the second sector. Then obviously the profit of $6 an hour in each sector, given the same capital labor ratio in each sector, will give you the same rate of profit. So the equalization of the rate of profit is also perfectly consistent with this pricing result. It's not a rule in the sense that it's desired. The pricing result, as long as capital labor ratios are equal. Everybody with me here? This is a very important point, very subtle, because it follows from this that what causes prices to differ from relative labor times is not the existence of class, not the equalization of wages, not the equalization of profit rates per se, but the inequality of technical conditions of production, to mention a phrase in Sraffa. The inequality of the technical conditions of production. And that means that it's only if capital labor ratios are different do we have any reason to suppose that prices will differ. So consider the next one. So imagine that now the capital labor ratios are not equal across sectors, which is obviously the general case. And go down and we will see, okay. So now suppose the capital labor ratios at the top are 30 and 90. These are very different now. Before I said they were each 60. But one is now 3 times as big as the other. That's a big difference. Everybody with me here? Well, that would give me a profit rate in the first sector of 20 and the profit rate in the second sector of 6.67. A big difference in the profit rates, right? One is roughly 3 times as big as, one is exactly 3 times as big as the other. So that means that capital labor ratios can have a big difference on profitability. But the question that Ricardo asks is how much does the price have to adjust to take into account such a big difference in the capital labor ratios? And if you can see right from here, we can we can figure out that the price that would make the profit rates equal, in addition to having equal wages, would be 140 and 130. I mean, you can work through the numbers of that, but it's pretty clear. These are the numbers. Then income per hour is 140 over 20, which is 7 in Beaver, and it's 130 over 10, which is 10. But wages are equal. They're $4 an hour, so that's equalization of wages. And profits are not equal per hour, but given the inequality in the capital labor ratios, the profit rates are equal, which is another way of saying that this set of prices is the correct set. I'm abstracting from feedback effects and all of that because I just want to illustrate the main argument, and Ricardo is more or less operating in that domain. So this have a very extreme difference in capital labor ratios, and you have a difference in prices, which are now different from relative labor times. Before they were a ratio of 2 to 1, now they're 140 to 130. So it's a big difference in relative prices, okay? And we need to go down one more. Oops, okay. Sorry, I cut off something, but it's okay. So, yes?
So basically this means that given differences in capital labor ratios, different commodities will have different prices, even though the profits are the same. So at which their profits will be the same. So those are competitive relative prices that are different from each other.
Not that they're different from each other, but they differ from the relative labor times. So the initial thing is up to the point where capital labor ratios are equal. We have capital, we equalization of profit rates, equalization of wage rate, competition. But the relative prices are equal to the relative labor times, direct and indirect labor times. So that's the beginning of the main proposition. Now Smith says, well, the principle will change. He doesn't elaborate on it. Ricardo does elaborate on it by trying to make a numerical example in which he argues that that difference will be small. And I'm going to leave it to Catherine to go through that numerical example in your lab because we have a spreadsheet and it's on your blackboard, and I made up a spreadsheet of Ricardo's numbers. You can change the numbers and see what happens. But then Ricardo, having arrived at this point, comes up with a question. Remember that this is an answer now, with capital labor ratios are different. But that raises a really interesting question. How different are capital labor ratios? And is it the difference in the capital labor ratios which is crucial, or something else? And I'm going to try to explain what I mean by that in a minute. But everybody with me here? So up to now, we've established that the prices deviate from relative labor times only because of the variations in the structure of capital labor ratios. Hang on, everybody with me there? Yeah? Yeah.
Could you say that in this case, the last square, the Ricardo's theory of value does not hold?
No, because Ricardo is the one who introduces this example to show that the theory of price must then be modified. So it would be like saying to me that if I observe that a ball made of light material falls at a different rate than of heavy material, does that mean that Newton's theory of gravity doesn't work? And the answer is no. It in fact shows you that at a certain level of concretion, other factors intervene. Right? And you know that from practice also, but it is quite a stunning thing to say that in the practice that we know, that a big object falls more slowly, a big light object than a small heavy object, underlying that is a principle that says actually in a vacuum they fall at exactly the same rate, and so their difference comes not from their mass or from the law of gravity, but the interaction of their shape with the fluid through which they're falling, their mass and their shape, right? And so we understand that principle, and that unifies a huge number of phenomena which would otherwise be a catalog of shapes all falling at different things. So he goes underneath and shows us, and this is exactly what they're trying to do here. And this is an important point because I'm going to show you it contains another question, which we don't answer generally, but we're going to try to answer today. Yes?
Could we then then say that the prices with which we started off are the relative prices, and these prices are the natural prices?
No, we're always talking about natural prices, not market prices.
I said relative prices.
Well, natural prices by definition are prices which give you equal profit rates, but the question we're concerned with is how does the ratio of natural prices relate to the ratio of labor times, not the absolute level.
And the relative price, because we had this discussion in the lab, like what's the difference between relative prices and natural prices, and no one could give
Okay,
a
let
convincing
me answer that.
answer,
So the term natural price means a set of prices that gives you equal profit rates. Now think about that. If I multiply everything by 2, all the numbers in here, I change the currency, so the price level goes up. Their ratio won't change. So what is of concern to Ricardo and Smith at this level is the ratio of the natural prices, not particularly their level. If they want to come to the theory of inflation or price level, that's a separate question. And so natural prices are indeed defined individually, but of concern is the ratio between them and the ratio of labor times, direct and indirect labor times.
So relative prices would then express the ratio of the natural prices?
Yes, relative price is another word for ratio of any prices. So we want to say relative natural price and relative labor times, or the ratio of natural prices and the ratio of labor times. Okay? Yes?
Just a small thing, I think there's a typo. The last year production box incomes per hour, it should be 13 per hour, just so in case people don't...
Yes, that's quite right. Thank you. As I said, I'm algebraically pretty good, but numerically I'm quite challenged. So this is something, thank you. Kathy, can you remind me? And I'll change, you can change it now, actually. Yeah, change it right now. Yes, thank you. Okay, now, here's the issue. Ricardo is not content with simply observing there's a difference. He wants to argue that this deviation, let's call it the deviation, before relative prices are proportional to, or equal to relative labor times, right? Now he's saying, well, they're a little bit different, or a big difference. So how big is the difference and what determines it? And he sets up a numerical example, which you will have the pleasure of working through in the lab. And that numerical example leads him to a particular hypothesis, or illustrates what he believes to be a practical insight, which is that these differences are not very big. And he does it by illustrating the numbers, but I want to try to illustrate that in another way. In this case, by waving my hands around, but we have a sheet also for the lab about that. But I want to see the logic of the argument. Ricardo understands that the price of something depends not only on the wages, but the cost of materials, and wages and profits, but the cost of materials, right? So price by definition is profits, wages, and materials. And that's because profit by definition is the difference between price and wages and materials. It's just the definition of profit. So you can say price is equal to profits, wages, and materials. Okay? Everybody with me? But what is materials? Materials is just the price of a bundle of goods. And by materials, I mean also depreciation of machinery and all of that, right? So I can take that bundle of goods and I can break it into profits, wages, and the materials costs of the materials. In fact, Ricardo's numerical example is precisely that. Only goes 2 stages only. Because the material, in this case the machinery, is built by hand. But I could do that analytically. The remainder of the materials, I can break it down into profits, wages, and the materials of the materials of the materials. You can see each time the residual is going to get smaller because it's a fraction of the previous materials, right? So intuitively, you can see that I can always break price into profits, direct and indirect, all the stages back, and I can break it plus wages, direct and indirect. Everybody see that? No? Should I do it again? Adam Smith did this in his head. So, that's the difference between geniuses and the rest of us. We have to write it out. So, think of it. Let's suppose that the price of something, if I get the number, if I say the numbers, I'm going to get lost, but let me try. Suppose the price of something is 100. And profits is 30. Wages is 40. And the materials is 30. So I've got profits. What did I say already? 30 and 40. And I've got residual 30. Now this residual I'm going to split into 3 parts. Profits, wages, and the residual. So the materials cost of the materials. So whatever they are, that is going to be less than the original 30 because wages is going to take 10, let's say. Profit's going to take 10. Wages is going to take 20. 15, and there's going to be 5 left over materials. And then I split that materials of the materials again and again, and I just add up all the wages, add up all the profits, and I show by just reasoning and easily by algebra even better, that you can always take any price whatsoever, market price, natural price, and break it into 2 terms. Direct and indirect wages, which are clearly proportional to direct and indirect labor time, and direct and indirect profit. That follows from just this kind of decomposition. So I can always break any price. This symbol means, by definition, I can rewrite it into direct and indirect wages plus direct and indirect profits. The ith commodity can always be broken into these 2 things. And this is not just a hand-waving exercise. With input-output tables, we can do this in a flash. Because it's just a simple calculation of inversion of a matrix. Okay? So now, if I know this, but what's this direct and indirect wages? In natural prices, the wage rates are all equal. So this wage bill is the common wage rate times the total amount of direct and indirect labor. That's capital lambda. Okay? Actually, let me not call it lambda. Let me call it LIT to be consistent. The wage rate times the direct and indirect labor time. Because the direct and indirect wages is just simply the wage rate times the direct and indirect labor time. And here we have the direct and indirect profits. This is, again, definitionally true, requires no assumption at all. And therefore, I can always write any 2 prices. I can always write this price as 1 plus the direct and indirect profit-wage ratio times the wage bill. Again, this is just a little manipulation of the terms, but that has an important meaning because this is the famous direct and indirect labor time of Smith and Ricardo. And this is the wage rate times that. Well, if this is so, then the relative prices will be the relative wages, wage bills, and the wage rates being common, because we're talking about competitive prices, so they have equalized wages. That drops out. And we have here a term, which I'm going to define, ZIG, 1 plus the profit-wage ratio vertically integrated of the ith sector, and 1 plus the profit-wage ratio vertically integrated of the jth sector, the total profit-wage ratio, direct and indirect. Hang on, let people catch up. So what I've done, since the wage rate has dropped out, I can get rid of that. And I've shown that prices are equal to relative direct and indirect labor times times a term, a multiplication term, right? So prices are a direct and indirect labor times times a disturbance term. This is the term that Ricardo is trying to ask. How big is this? Smith also knows it's there. Marx also knows it's there. But people don't ask formally what determines its size. I saw a hand. Yes?
What happened to the residual?
Well, the residual is already counted in these direct and indirect labor times. I mean, suppose I take a price and I say it's equal to the wages plus the profits, plus, let's call this the materials. That's just a definition, right? But I know that the materials can be split up now into the wages of the materials. I'm going to use a 1 there to indicate one stage back, right? Plus profits, one stage back, plus the materials, one stage back. I can do that. I mean, I can just take the bunch of goods that you use. I can go to the input-output tables and say that collection of goods that you use for inputs has a wage bill, has a profit, and then it has a bunch of materials it uses. This is what input-output tables allows you to do. Well, already, so if this number was 30, then these 3 must add up to 30, which means this has have to be less than 30. This may be perhaps 5, so the residual is 5. Then I do it again for that residual. And that will have a leftover, perhaps 1. And I do it again, the leftover will be 0.2, and so on and so on. And I can see that intuitively that leftover goes to 0. So what I get left, if I do this, I end up saying, well, the wages can be made up of the initial wage bill in the industry, plus the wage bill in the industries that provide the raw materials and machinery for this industry, plus the wage bill in the industries that provide the materials and raw materials for the raw materials and so on. And this is really an infinite series. Plus the profits. That's all that's left. Because in the limit, all the other terms go to 0. The residual goes to 0. So I can call the first set of these things WIT, and I can call the second set pi IT. It's just a number. And we can actually calculate this extremely fast now with the computer. So analytically, the point is that we don't need to know the number. What we want to know is the property of the number. And there's a very interesting implication here about the property, which supports Ricardo's argument that these deviations will be small. Okay? Yes?
The derivation, where did the L disappear in the third equation? When we factored out the WIT, then it's one, where did the, on the bottom?
Yeah.
The one before it. The one
Here?
Before this one, yes. I just want to know
Ah.
the denominator. Why
Here?
the L, yes.
Because capital W is the wage bill is W times LIT. So I can either write it as capital W or small w times LIT. Okay? But the advantage of writing this way is you see intuitively what it means. It's a profit-wage ratio. And that's crucial to the next step in the logic. Yeah. Yes?
What exactly is direct profit?
It's the profit implied in the raw materials that you purchase. Let's suppose, think of it this way. Suppose I say to you, look, I observe that I make bread. So I have a certain amount of profit in the bread and a certain amount of wages in the bread. Of course, I need flour. But flour is just profit and wages of the flour producer, plus whatever the flour producer uses. So I add that to this, to my profits, instead of writing it out as wages and profits of the bread maker plus raw materials. I break the materials down into their wages and profits and add that here. And then the residual I keep on adding. That's just what I'm doing here. So intuitively, I can say bread can be thought of in 2 different ways. Profits, wages, and flour, cost of flour, or profits of bread and flour and all the other things that go into making the bread, and wages of bread and flour and all of the other things that go in making in the flour, right? So oh, it is a cost, yes, but it's breaking the cost down into its direct and indirect wage components. So all of these indirect components reflect not merely the cost, but the structure of production. If I were to assign you to do that, you'd have to run around from one sector to another tabulating the thing, or you can go on the BEA and look up the input-output table and do it in a flash. Yes?
Is there any room here for the value of the process? So let's say there's a process invented to make flour, and then a process invented an idea to make flour into bread. Or is that lumped into profit?
No, it depends on whether it's a cost to you or not.
No, I'm saying the value, if somebody came up with a...
No, but keep in mind this. If I take profit, if I define a price, I can always write it as a sum of its costs and its profit, because profit by definition is the difference between the price of something and what you paid for its inputs. I mean, if you get good air free, it doesn't matter. Your profits are not affected. I'm not trying to explain whether profits are justified. I'm just measuring them. And the measure of profit by definition is my sales minus my costs. So if I've got a cost for something, it's going to show up there. And that's what happens in the input-output table. We're not in any way talking about the justification. We're just concerned with the measurement. This is why, that's why it's an identity. It's a balance sheet. It's a profit-loss statement. That's all this is. But in Smith's hands, this becomes something grand. And that's what I want to get to. Yes?
Isn't that an endless process?
Yes, indeed. Indeed. But that's the whole beauty of what's called an infinite series in algebra. An infinite series is an endless process, but it doesn't follow that the total is indeterminate. Remember that part in algebra? Remember that part in high school? If I write a series like this, 1 over 1 minus 0.5, this can be written as 1 plus 0.5 plus 0.5 squared plus 0.5 cubed, and so on, infinite series. But we know perfectly well that this is a determinate number because this infinite series adds up to a specific number. Right? And you can look it up. It's a standard formula, 1 over 1 minus x. And you can see immediately that we know from the theory of limits that this is a determinate number. But intuitively, you can see that because you keep adding a smaller and smaller residual. That means you're not going to change after you get to a certain point. In computers, you don't do it algebraically. You do it by simply doing the iterations, certain number of stages. But after a while, you're adding a number so small that the computer can't even keep track of it. Then you know you've reached the correct total. OK, good question. Yes?
Could you tell me how profit rate is calculated? It's like profit over P minus...
This is just definitional. We're not calculating. We're just looking at profit per unit output. So if I say to you, look, the price of bread is $10. My wages are $3. My flour is $4. What is my profit? It's the difference between $10 that I get for selling the bread and the $7 that it costs me to make the bread. By definition, it's 3. Now, because it's by definition 3, I can rewrite price as the sum of profits plus wages plus materials. It's purely an accounting identity. There's no, and the profit can be negative, by the way. It doesn't have to be, I mean, obviously, if you're selling the bread for $7, your profit is 0. Selling for 6, you'll have a loss.
I mean, in that table, the profit rate is 20%, and it is maybe profit over capital. So it's not included wages. I mean, the cost is, there's no wage in the cost.
No, there's a wage right here, wage per hour.
I mean, when you calculate the profit rate, 20% or 6.67.
I didn't specify actually what is in capital. That's a good question, but if you were doing it concretely, you'd want to look at machinery plus inventories, and Marx would especially insist on this, the stock of money that you hold to conduct your business. Okay? So, yes, at a more concrete level, the wages will show up, but not directly, because you don't need to hold $1,000 every week just because you pay $1,000 that week, because you're putting that money into the wages, but you're getting money out from your sales, right? So there's a relationship between turnover time and the money you hold and all of that. And more concretely, between that money you need to hold or the credit account you have with your bank. So they hold the money and you don't. And so it's moved out of your balance sheet to theirs as reserves. So at a more concrete level, that's quite correct. But at this level, the point is that it's perfectly general. The logic of this doesn't depend on the details. Okay? Though the number depends on the details, but not the logic. So now I need to get to the point, the punchline of all of this, which is that if I end up writing this kind of relationship where relative prices is equal to relative total labor times, direct and indirect labor times, which is the original number we started with, right? Times a disturbance term, then we need to know what causes the disturbance term. Why is it what it is? Well, we can observe several things. Suppose that profits was 0 in every sector. Which is another way of saying the profit rate is 0. If the profit was 0, then every pi I is 0 in every sector. So the sum is 0. So therefore, this becomes 1 plus 0 over 1 plus 0. So what's the ratio of 1 plus 0 over 1 plus 0? 1. So there's no disturbance term if the profit is 0 or small. So intuitively already we can say that the disturbance term depends on the size of the profit rate. Okay? Size of the profit-wage ratio. The profit-wage ratio in advanced countries in the order of 0.25, 0.3. So then we're talking about a number which is 1 plus 0.3 plus or minus some number here or there. And you can intuitively see immediately that then the dispersion matters too. Because if this is 1 plus 0.3 plus 0.1, and this is 1 plus 0.3 minus 0.1, that's the dispersion term, right? So then you have 1 plus 0.4 and 1.2, 1.4, 1.2. It's a number different than 1. I can see the disturbance term, but I also know it's a number not very different than 1. So intuitively, two things matter: the size of the profit-wage ratio and its distribution, its standard deviation or coefficient of variation, or generally its dispersion. Everybody with me here? Now, here we come to the punchline. What we are concerned with is not merely the profit-wage ratio, but the vertically integrated profit-wage ratio, the direct and indirect profit-wage ratio in every sector. And modern economies, by their nature, are connected. So if I buy flour, if I make bread, I not only pay wages and profits, but I have to buy flour. But flour is made with machinery. And machinery requires steel and plastic and trucks. So I have a portion of the profit-wage ratio, because the vertical integration picks up everything that in my inputs. My profit-wage ratio vertically integrated, or my total profit-wage ratio, is not only mine, but a portion of all the inputs that I use, portion of their profit-wage ratios, plus a portion of the inputs that they use, and a portion of the inputs that they use from this, and so on and so on. And it's easy to show that in an economy that's connected, my vertically integrated profit ratio, wage ratio, will be a weighted average of all of yours, each one of you being a different industry. All right? So vertical integration will make mine move closer to the average, because it's going to pick up a little bit of everybody. So even if the direct ratios are big, when I replace them with vertically integrated, which I need for this decomposition, they're going to be closer together. Well, it's not just true of mine, it's true of every one of yours. Your vertically integrated is also going to be closer to the average. So intuitively, you can see that the thing that matters is the dispersion and size of vertically integrated profit-wage ratios. And these ratios are going to be moved towards the mean of the direct ratios simply by the fact that it's what counts as vertical integration. This is a big insight. It's in Smith, and it's explicit in Sraffa, and of course Sraffa's followers, Passinetti and others. But the main point is that once you understand that, then you have a handle on Ricardo's sense that this number cannot be very different, is not likely to be very different to 1 on average. Of course, some sectors may have a lot, and some sectors may be very close to 1. But when you look at their mean deviation, means absolute deviation, Ricardo's hypothesis can be thought of as saying that this mean deviation is small. So that first proposition would say that relative prices are roughly equal to relative labor times, plus or minus an error term. Now notice, this is a product. So I can write it out as a log sum. The log of this is equal to the log of this plus the log of that. So that's a log linear relationship with a term that can, in effect, function like an error term. It may not be, IID or anything, but it'll be an error term. And this is a common problem in engineering. A multiplicative relationship which translates into an additive log relationship, and we're concerned with the size and distribution of the log of this term. That's a question we could not answer till the 1950s because there was no means of doing it. We didn't have computers, and we didn't have input-output tables. Input-output tables were developed by the Soviets for planning, and computers were developed everywhere, so to speak, for the same reasons and other reasons. And so computers and input-output tables are relatively recent. When I first came to the New School, I was a graduate student in Columbia, and I got a job at the New School. And I had seen a pattern in the data, which is that I found data in an article by Leontief for relative prices and relative labor times. And I noticed that these numbers were similar, it seemed to me. And in the back of his famous Hector-Lean article, Leontief paradox article, it's the appendix there. So I'm going, I know these are similar, but what do I do with that? So I went to the school and it said, I need my computer account enabled because I need to put these in those days, cards and all of that stuff, run them through and see. And the New School said, we don't do computers. We don't have a computer. So in order to do this kind of calculation, I had to have it done at MIT by a friend. But when I did it, you're going to see what we see. Because then I was able to duplicate it. Once personal computers came, I could do it here. And the results are quite striking, but they are very consistent with Ricardo's insight that the dominant term is here. So that's the first insight. Now, second implication of this, if there's a proportionality between relative prices and relative labor times, even if this number is not small, but especially if it is small, then the changes in relative prices over time will be determined by structural elements, direct and indirect labor time. So that's a very powerful empirical hypothesis that the structure of relative prices in advanced economies that are relatively closed, because when you talk about trade, you have to add on all the disturbances with trade, which are determinate, but you have to do that. But in a big economy like the US, you'd expect to see a strong correlation between relative prices and relative labor times cross-sectionally, across sectors. And then over time, we expect to see, comparing 1958 to 1972, the changes in one set of relative prices and the relative labor times should be highly correlated. That's Ricardo's two hypotheses, the cross-section and the time series hypothesis. Yes?
Regarding, so let's say, if we put this theory with trade, imports and exports between countries, what exactly will happen?
I haven't come to Ricardo's theory of trade, let alone mention any concrete theory of trade. So the answer is we cannot say a priori. We can say some things, but I want to reserve that because until we know how Ricardo deals with rent and trade, it won't make sense. Yes, any other questions? Anyone else? Yes.
Is it possible to find the not relative price, but the absolute price, like using MOMI or?
Sure. When we measure empirically, we have the price. I know the price of cars, but the problem is that when we're talking in input-output tables in practice, we don't have a single industry like a car. We have automobile industry, which is a whole bunch of different cars. So we don't have a single car price. We have a weighted average of car prices, and then we have to deal with quality change and all that. So you end up with index numbers. So you end up with a kind of relative price anyway. But the hypothesis is about relative price. There's nothing here about the question of the price level. Ricardo would argue that's dependent on the quantity theory of money. So all prices might go up and down as the quantity of money change, perhaps not in equal degree, but the relative price question is about relative natural prices, competitive prices.
So we don't need any money theory to explain.
No.
Relative.
No, because we were speaking of relative prices. In their monetary theory, the price level, which is a multiplication factor for every price, so to speak, is determined by different factors. The theory of money, typically, in Ricardo, but not in Marx, let's say. Other questions? Okay, now time for punchline. So we now switch to the data. But let me explain what the data has to be. On one side, we have relative prices of sectors of the US economy. Now Ricardo is talking about natural prices. But an interesting question arises. What if we add on also all the disequilibrium phenomena of market price? Because natural prices are wages are equalized, profit rates are equalized. But in practice, as I've tried to argue, these were never actually there. You're always fluctuating around the center of gravity. So you observe market price, you expect this number to be, this distance to be greater. The distance between the relative market price and the relative labor time should be much bigger because you've got all the turbulence. It seems plausible anyway. So by looking at the market price and relative price thing, you're looking at the upper bound. Now, I can actually calculate the other numbers, but I want to show you that this is something which is always there. It's in the Leontief article. And so take a look now at the data. This is data from my article in 1998. It's called The Empirical Strength of the Labor Theory of Value. And understanding here that the labor theory of value in the Ricardian sense means a relative theory of relative price. Because value means exchangeable value, relative price, okay? So this is the labor theory of relative price. And we're asking, the first hypothesis is it plausible that relative market prices, so on this axis, prices proportional to labor time, which is relative labor times on this axis, and market prices on this axis. Now, I will produce some numbers in a moment, but you can see intuitively, visually, that this is a very tight relationship. And this is for the US economy in 1947. In my paper, I have it for all different years, but I just need to illustrate because all the results are the same. So now we go down. So this is 1958. You notice that the character of the relationship is essentially the same. It's 9 years later. 47 was right after World War II. There's a lot of turbulence in the economy and all that. And yet, then we go down to next one. This is 1963. This is data that was produced by a student in this department, who's now president of a college by the name of Ed Ochoa. And this was his PhD dissertation with me. He was the first person to do these kinds of measurements on a scale. And he had to do a lot of the actual calculation and work on a computer and all that because we had very limited facilities, including no programs to do inverses and all that. He had to write all that stuff. Hang on, let me just run through them. The next one is 67. And the one after that is 72. So you get an idea. Now, the main point is you can quickly see that this is a very tight relationship. There's not a regression. The line here is not a fitted line. It's a 45-degree line. It's just a scale, a reference point, because if they were all relative prices were equal, everything would be on the 45-degree line, right? If these two, if this was equal to the total labor times ratio, then I could scatter them and they'd be exactly on a 45-degree line. So the deviations from the 45-degree line tell you the effect of this disturbance factor. And it is indeed a disturbance factor. I saw a hand somewhere. I saw somewhere here, though. Was it? No? Okay, yeah.
Just for clarification, each data point represents one industry versus another industry?
Each data point represents industry I. This is the, I switched them, I think, yeah. This is the market price, and this is the vertically integrated labor time. So here's the vertically integrated labor time, here's the market price.
Each dot represents a different industry?
Yes, each one represents it. And I believe here this was 82 sectors. We have bigger tables, but we had to make all the tables consistent. So the smallest one sort of determines how you're going to go through if you want to make comparisons over time, which I'm going to do momentarily.
So for the visual representation, you basically switched around
that equation to come up with ratio?
Yes, because in some of these, they were plotted. Well, I mean, since we're asking what's the relationship between these two, we can technically put either one on the horizontal axis and the other on the vertical axis, right? So if they're equal, it will make no difference. But if they're slightly unequal, also makes no difference.
Right now on the vertical axis is PM, that is market price over PD.
Vertically in labor market price in advanced countries. This is actually, yeah, labor, vertically integrated labor coefficients on this axis, and here market prices on this axis.
It changes from one.
It may, because it shouldn't, but it probably does, yes. Because they were done on different, well, it shouldn't.
For the first three.
I see, yes, because I think I copied this from an earlier thing, and these are done in MathCAD, so it may be reversed. But the point is that if they are close, they'll be close around 45 degrees. Okay? Now some numbers, because we want to know how different are these. We're not running a regression, because regressions may have some problems, because both of them have scale. So if you run a big number against a big number, they'll seem close together. So what we want to have is some measure of vector distance. How far are the two vectors apart? And there are standard measures for that. What we're looking at is the mean absolute weighted percentage deviation. That's a lot, mod, but it's actually not very complicated. What that means is I look at the deviation between relative price and relative labor time in industry 1. It's some number. And I then add it to that in industry 2. Mean, so it doesn't, if this is above, a positive number. If this one's below, I still have a positive number, because I'm only interested in the size of the deviation. And I weigh them according to the size of the sector. If it's a big sector, it gets a big weight. Small sector gets a small weight. Because otherwise, a small sector can have an undue effect if it has a very big number. So that's a standard weighted deviation, mean absolute weighted deviation. And you can see that if you compare what I call vertically integrated unit labor costs, which is really this term with the wage on the numerator and the denominator. It cancels out in relative times. But think of it as directly indirect labor times versus market price. So this versus market price, the deviations are on the order of less than 9%, average deviation. That's essentially Ricardo territory. And this is market price, by the way. Then we also calculate prices of production. That is to say, natural prices. So that's Ricardo's question. He wasn't so interested in the market price versus labor time, because he was interested in the center of gravity of market prices. And that was prices of natural prices. And so we asked that question, and you see that they are only slightly closer. The average is 8.2%. Everybody see that? Market price versus direct and indirect labor time, relative labor times, 10%, 9%, 9.2, 10.2, 7, and an average of 9.2%. Natural price versus market price. Price of production is Marx's term for natural price. 11, 7, 7, 8, 6, average of 8. Now that's Ricardo leaping up from the grave. Told you so. And remember, this is 100 and more years later. And Ricardo's writing in the 1820s, so we're talking of almost 200 years later. And this is versus market price. Now, and this is the key thing that Ricardo's interested in. The relative labor times and natural prices. VULC stands for vertically integrated unit labor costs, which is the same thing in this context as relative labor times. 5.5, 5.6, 3.8, 3.8, 4.8, 3.8, and 4.4. That's Ricardo exactly said the upper limit is 7, and this fits in that bound. But it wouldn't matter if it was 15. The fact is that the remainder would be 85. Here the remainder is 95. Now this is actual data, but you cannot get this result without thinking to look for it. Because people have been using these input-output tables since the 1950s, but they weren't looking. And that's the importance of theory. Theory gives you a question. Can't determine the answer. That's reality's role. But if you don't ask the question, you're not going to see it. And Ricardo asked that question. Okay. Any questions? Okay, so we have come to a very important point, which is that we've established that Ricardo's instinct was empirically correct. And Ricardo's specific example is one in which he says, well, if I change wages and profit rates change in the opposite direction, the effect of those two changes tend to cancel each other out. If I raise wages, then my wage costs go up. Everybody's wage costs go up. But if I lower profit rates, then everybody's profit component goes down. So the two effects counter each other. Obviously, sectors which have a lot of labor relative to capital will have a big effect from the wage rise. And sectors which have a lot of capital compared to labor will have a big drop compared to, due to the profit rate drop. So his point is that these effects go in opposite directions, and on average, they tend to be small. Not that they're zero, but they're small. And that hypothesis is something that was actually tested by one of the most famous mathematicians in the United States by the name of Jacob Schwartz, who was the professor at the Courant Institute of NYU. And it's on your readings. What Schwartz did is realize that you could test this hypothesis. What is the hypothesis? The hypothesis is that relative prices will not change very much if we change only distribution and not the structure of production. Right? That's a hypothesis that says if we can test a situation in which distribution changes, profits and wages change relative to each other, even if profits just drop, then I expect that because this term is not changing, that relative prices will change on the order of 7%. That's Ricardo's example. That's what it's all about. So then the question is, how do you do that? How do you take a hypothesis like this and without some huge apparatus, like I did with input-output tables and constructed, and Schwartz did it in a simple and brilliant way. Yes? Yes, the hypothesis is, Ricardo's numerical example says, look, if I can change the distribution of profit-wage ratios without changing the structure of production, which is what his numerical example is, then I expect that this change here will have a small effect. So that tells me the sensitivity of relative prices to distribution, as opposed to the sensitivity to the structure of production. Obviously, the sensitivity to distribution is small. The sensitivity to the remainder term, which is a relative structure of production, is large. So if that second term has a small effect, the first term has a big effect. Okay?
Variation of Z should not have a big effect
on relative prices, that's right, on the left-hand side. So now here's the question is, how do you test this? And what Schwartz did was say, well, look, what are the moments when distribution changes, profit-wage ratios change dramatically, but there's no change in the structure of production? And the answer is from the peak to the trough in a business cycle. Because in a business cycle, people don't add new capital. They pretty much got what they have. They may lose some, but pretty much the structure of production stays the same. But what happens is prices drop, market prices drop, and profits and wages drop. So if we can see how big the relative prices change is from peak to trough, we're basically testing the sensitivity to this term. It's brilliant. And so he does it. It's in his book, which is on your readings. And he comes up with a number, which he finds empirically. And that number is 7%. 7%. And yet in all that literature about Ricardo and how stupid he was, he doesn't understand capital-labor ratios and capital and all of that, people didn't ask the question that was there until someone smart enough looked at it, and that was Schwartz. Okay? So that is, again, I make the point, theory is very important because it gives you questions. can't give you the answers, but it gives you questions. And questions are really important because then you find things. All right. So now, that is the first set of these is all about the sensitivity of relative or the deviation of relative prices from relative labor times, which is another way of saying the structural relation between market prices or price of production and the structure of production. And that tells us a lot, because if this is true that they're tightly related, then it would be true that changes in relative prices would be dominated by changes in the structure of production. In other words, this is a classical theory of relative price. It's not about utility maximizing and rational consumers and the tiniest little change causing everybody to switch to a new thing. This is about the structure of production and prices in a turbulent equilibration process. And I can calculate those numbers, actually, because I can calculate prices of production, and not just market prices. But market prices presumably would be the biggest deviations. So what we did, and this was done by another student by the name of Ed Chilcote, who also sat in this class at one point and then became a banker with Citibank and then Barclays, and now is well off enough to be retired, which is lovely. But this was a very nice dissertation. And what we're looking at here, what is that? Hang on a second. You know what? This is the wrong, I thought I had the, yeah. So you just have to keep scrolling down because this is the wrong, no, it's correct, but I thought I cut out all this other stuff, and I'm only interested in the interest of time, in a set of, here, right here. What we're looking at here is now taking this hypothesis and saying, if I observe the change in this ratio from 1958 to 1963, let's say, right, for every industry, how closely related is it to the change on this side? So this is what I call the temporal hypothesis, that changes in relative prices over time are dominated by the structural change in the economy. Direct and indirect labor time is a measure of that structural change. So here we are plotting on the vertical axis the changes in market prices, and on the horizontal axis we're plotting the change in the relative direct and indirect labor times, weighted by wages. So we call it relative unit labor costs, real vertically integrated unit labor costs, right? So you can see that these are quite tight scatters. And this is quite turbulent because we're talking about a difference from 1958 to 63. It's a 5-year variation in prices. How much of the 5-year variation in relative prices in economy sectors is explained by the 5-year variation in their direct and indirect labor times? And this is now comparing 1958 to 1967. Now look at something interesting. In the shorter period, there's more turbulence than in the longer period. Because, I don't know because what, but anyway, we observe that a 9-year period gives you a tighter scatter than, whatever that is, a 5-year period, right? So the first one, 5-year difference, 9-year difference. Now let's go down to, whatever that is, 14-year difference. And you see the scatter actually gets tighter. This means that we have a tool for long-run analysis. We can say that this is the long run. Over the long run, relative prices are dominated by relative labor times. And I can tell you, theoretically, this is a very powerful tool because when you're doing practical work, if you can say that you have these dominant characteristics, that's extremely important. And I'm going to come back to what they mean in a minute. So let's go down one more. 58 to 77, a longer time period, and 58 to 82. Now, you can't see it quite here, but as you get too long, the differences become wider again. So there's a kind of period of, say, 12 to 14 years over which the connection is strong. And that's another way of saying that's the definition of the theoretical definition of long run, practical definition of the long run. Now, interesting enough, 12 to 14 years is the definition of the cycle, the so-called cycle in the classical tradition, which is 10 to 12 years, not what we call the cycle, which is a short-run inventory cycle, but what they call the cycle, which is the fixed capital cycle. And just perhaps coincidentally, but perhaps not, this is on the order of that second cycle, the proper dimension. And there's a lot of work that can be done on this. Okay. I keep going for the distances. You can see that, as you get further, some of it is data differences. Okay, that's fine. These are different numbers here. Did I have anything else to say? Yeah, we can stop that. Yeah, so now what have we established? We established that there's a hypothesis in Ricardo about relative prices and relative total labor times. We established that the hypothesis has two dimensions. One is the sensitivity of relative prices to distribution, and the other is the sensitivity of relative prices to changes in structure of production. And we find the data very strongly supports Ricardo's argument. And I've tried to show you that the argument didn't just come from some fantastic vision that he had while smoking something. It came from logic, a deeply rooted logical argument. I'm not knocking the other type of vision, but you do have to establish it for other people in some way, and this is where logic comes in handy. Okay. So, any questions here? I have some time, so I can pick up another issue, which I would like to do, the Ricardo theory of rent. Any questions here about this business? Yep. Imagine that we have written a strict, yeah.
It's really difficult to follow because we can't see the equations.
Yeah, the trouble. I can put this up. We can put this up, and I can do that again. Yes, good point. That's the trouble. Our technology is kind of primitive. It does not allow you to watch the screen and write at the same time. So, okay, we established this is an identity. This is the relative labor time term. And here's the disturbance term. Right, this is an identity, so it's always true. It's just a decomposition that we did in the logical way, a counting identity. But it's very clever because it relates back to the classical hypothesis. So the question Ricardo is asking, one way to think of what he's asking is, how sensitive are relative prices to variations in this alone? Right? Now Ricardo says, imagine a situation in which wages were to rise. Well, all the profits would fall. But they won't all fall to the equal degree because it depends on how big wages are in your sector. If you have an agricultural sector and wages rise, lots of labor, then your profits are really going to be hit. If you're using a high-tech sector and you have just a few workers and your wages rise by the same percentage, your profits may not be hit so much because your wage costs are small. So he understands that there is a kind of twisting to the effect depending on the size of your capital labor ratios. But he says, notice that if you look at these, both will fall. So in that sense, they kind of cancel each other out. But they won't fall to equal degree, so there's a kind of twisting. And I'm arguing that, he's arguing that that twisting is what accounts for the deviations. If they both fell by the same amount, the ratio would stay the same, right? So clearly, it's a twisting that accounts for that. And his numerical example leads him to believe that this change would never be big enough to account for more than a 7% movement here. And he says that's an upper limit. So his hypothesis is that this term has at most a 7% influence. Now, one could argue it's wrong. We can test it, but you certainly have to ask how to test it, and that's what I've been trying to show. Any other questions? Yes?
I don't think we can see the identity.
You cannot see the identity. Okay, I will write it up higher. It's too low? Ah, okay. This is where good technology certainly matters. You can see that, right? And that's your famous relative labor time term. Now this is an identity that we derived, and we can derive again in lab. 1 plus the profit-wage ratio in the ith sector, vertically integrated profit-wage ratio on the numerator, and 1 plus the profit-wage ratio of the jth sector, vertically integrated in the denominator. I and j are arbitrary, any two sectors, so it doesn't matter. Hang on. People are a little lost in the algebra.
Is profit wage the same or equivalent to capital labor ratio?
No, because this is the profit rate times the amount of capital, and this is the wage rate times the amount of labor. If profit and wages are equalized across sectors, then the difference arises solely from capital labor ratios. Because I can always write the profit-wage ratio as, in prices of production, natural prices, as the common profit rate times the vertically integrated capital, common wage rate times the vertically integrated labor. So obviously, the only difference can come from there. That's a good question. Hang on. Are you caught up with the algebra? Okay, does it make sense? So now you're Ricardians. I saw some hands, so yes.
If a car is $100, and then you can still say that there's a certain amount of labor embedded in that price. I mean, if the car is $100,
I can just look at the car production and see how many workers are employed. There's no big deal. I can count the number of workers. That's what an input-output table does. It tells me the car is $100. Of that, 60 went to labor. At the wage rate of 2, that's 30 workers. So I count the number of workers.
you can say then that the price is related to the labor input. I mean,
No. Price by definition, this is an identity. By definition, profit equals price minus costs. That's just a definition. That's how we know what profit is, right? So therefore, I can rewrite this as price is equal to profit plus costs. And costs I can break down into wage and materials costs. And when I do that, the materials is just the price of a bunch of goods. So I can break it down again and again. But this is purely an identity. There's no theory of what determines the size of this needed here. This is purely based on accounting identities. Is that point clear? Because I think some people are puzzled by that. Obviously, not many of you work in the private sector, because otherwise you'd know this, that profit is by definition what you get minus what you paid. And it can be negative, can be 0, but this is still an identity. And when we measure this actual number, we're looking at actual profit, actual prices. It's just purely an accounting identity. It's not saying that profit price is created by marking up over costs. Maybe that's where the confusion is coming. Because any price and any profit will result from whatever you can sell it for and what you have to pay for the cost. If you happen to be in trouble, well, that's too bad. If you're doing well, that's great. But it doesn't require any theory of price. We're just observing your sales, observing your costs, and calculating your profit. And then by definition, this is an identity. And since it's an identity, it's equally true that the other side is an identity. Questions? Yes?
Professor, so when you have this data, you're actually observing the market price. So is this how you come up with natural price that you say, okay,
Very good question.
If the profit rates were same, then what would be the prices? Then those are the natural prices?
No. Yes and no. You can write natural prices or prices of production analytically in such a way that they do not depend. You can show that the calculation does not depend on the observed market prices. Because basically we're saying we take the input-output structure of technology, the wages, and we ask if there's a given wage, the corresponding profit rate can be calculated from that, and what prices would give me this profit rate. And that's hypothetical prices. And that's what we're calling prices of production here. Indeed, that's a definition of prices of production. But I also observe actual prices. So the point of the data is that they're not very different. But the fact is we look at actual structure of production, direct and indirect labor time, actual profit wage ratios, and actual prices. Then we say what prices would give us equal wages and equal profit rates a la Smith, Ricardo, and Marx, which you can do thanks to computers. And that calculates it out for you. And then you can say how are those relative prices related to the structure of production, which we're not changing here. We're just trying to see what the effect of price profit rate equalization is or of competition is. So we have a set of competitive prices. And as you can see from the structure of these tables, that is a second order issue. It's relevant and we can analyze in more detail, but the main point is that the differences are on the order of magnitude that Ricardo was talking about between any set of prices and labor times, direct and indirect. Yes.
This 7% is a long-term number. It's not, for example, because let's say relative prices of the long-term economy.
No. No.
That would be also
In Ricardo, yes, because the number he posits is that this would be in a time long enough for market prices to be roughly equal to price of production, to fluctuate above and below them, right? So that's he's calculating, but theoretically when he's calculating, he's just assuming that those prices reflect equal wages and profit rates. When we calculate, we can calculate them just like he did. I can say these are the market prices, but I can tell you in that same year, 1958, what prices would have given me equal wages and profit rates. That's a straightforward calculation. How different are they from the market prices? That's a straightforward comparison. How different are they from the labor times we observe? That's a straightforward comparison.
But let's say for example, is it not possible that certain prices in the distribution could be much higher than the ones within production? So let's say this is the
Yes.
relative price of production. but
Sure it
what's the
is.
distribution?
It is possible, but the fact is it doesn't appear in the data because these are relatively aggregated. These are 82 sectors. That's a lot of detail, by the way, 82 sectors. We go in some of these to 173 sectors. Yes, we do find periods and moments where this matters. The price of oil shoots up in the oil crisis in the 70s, right? So that's not a surprise. We already can explain that. It also comes back down to its same relation before. We can find the more finely detailed you get, well, obviously these factors matter. But if you're taking a big sector like automobiles, then you might find a big hit in 2007. We know that happened, the price of automobiles and all of that. But so you'd expect to see a bigger dispersion. But you don't see, for any one sector, yes. But when you average out these things, no. That's the point. The average is very important. And not saying that the average is the only number, but clearly for Ricardo, you want to have a sense of the relation, the general relation. And yes, you can then use this to plot relative prices over time of each sector versus its relative labor time for each sector. But that would take too much space here, but it can be done. I do that elsewhere. Yes?
Quick question. When we speak about sectors, it's goods and services in Ricardo.
I'm using the term sectors actually in the sense that input-output uses industries, which is their definition of aggregate things. And you can get a lot of detail. You can get 450 industries. But then it's hard to find all the relevant data. We have to match wages because you need wages for this too. And capital stock, which are very complicated. So you have to aggregate the input-output table to the level to which you can match the other data. But we have, let's say, between 82 and 172 different industries, meaning industries in the broad input-output sense. They have a very precise mapping from SIC codes to input-output industries and all of that. That's a well-established discussion. But, 172 numbers here. How far are they from the underlying 172 labor times? And the answer is not very far. Now, if I go further and further down, I go further and further down in narrower in time, well, of course, I would expect that. That's part of the turbulence equilibration process. It's a different question to ask, are relative our profit rates roughly equalized? We will come to that. But for now, we're asking Ricardo's question, assuming they are, or even assuming they're not, how far are the relative prices from the structure of production? The answer is not far. Remarkably close, in fact. Okay. So I have a little bit of time, and I really, really would like to get to one more topic. And I'm going to give you a choice, the theory of rent or the theory of trade. I'll do the other next week, so it doesn't matter. Both follow directly from here. Rent.
Yeah, I've been reading some trade nowadays.
True. Well, I'll pick up trade next week. Let me do the rent is because I can do it in a more short rent. Trade requires more elaboration. But here's the issue in the theory of rent. So far, we've assumed that the price of a commodity is subject to profit rate equalization. And so therefore, that market price is regulated by a hypothetical price that reflects equal profit rates. That hypothetical price doesn't actually exist, but we can calculate. We can ask, does it actually act as a center of gravity of market prices, right? So then the question arises, we're analyzing these centers of gravity, these natural prices. How is the story changed by rent? And specifically, does not rent add a number to that price based on land, quality of land, and therefore causes another series of deviations? Remember, where we're coming from is that these deviations are small, so maybe rent could arbitrarily change that. So part of Ricardo's great contribution was to show that the theory of rent does not change the relation between market price and natural price because it defines a different natural price which regulates the market price. Let me say that again. Market price is still regulated by a natural price, but now you'll have to ask which natural price, because if you have quality of land differences, then each land will have a different potential natural price. And the question is, which one is going to be the one that dominates the market? Okay, so I'm going to act it out, Ricardo's theory of rent. Okay, imagine that this is all the available land, the ground, right? And here we are in a country, this is Ricardo's analogy. We have a country which is using some of its land. And that land has a particular price, cost, and natural price. Let's say that natural price is $10 per bushel of wheat. Okay, everybody with me? On this quality of land. Now the country is growing, demand is growing, and as demand is growing, you produce more wheat. But if you've got that quantity of land, quality of land not used up, the natural price will remain at $10. You just keep expanding production. You use up more of the fallow land and all of that, and you keep going. So this is the first important point. Natural price doesn't rise necessarily with demand as long as you can reproduce the product, which is, remember, the key point in Ricardo. I'm talking about, he says, reproducible commodity. So if you have available land of a particular quality, we're going to start with that first square, and then we're going to move out from that square, and we keep expanding. And at some point, we're going to start reaching the problem that we're running into a limit in that land. Now what happens if the demand for wheat rises, but you can't produce any more on that quality of land? The answer is, until you can bring another quality of land in, the market price will be determined solely by demand. Remember Ricardo's second category of goods, which is whose supply cannot be expanded, and therefore their demand determine their price. So the price is rising. So it goes from 10 to 11 to 12, maybe 13. It goes to 13, people go, wait a minute, there's land here that I can produce at a natural price for 12. So now production here starts. As production starts, it brings the supply up and the price falls. But where does it fall? Not to the 10, because that land is already fully used. But it doesn't stay at 13, it comes down to 12, and it fluctuates around 12. So what happened? We moved from the best land to the next good land, and the price went from 10 to 12 with an adjustment process. Now you can imagine there's another land up here, it should go to 14, and so on. And so over time, in Ricardo's vision of this, the price of corn would rise as you move to better lands, to worse lands. But at each moment in that process, except for the transition, the price is regulated by a natural price, which is the natural price of the land which you need to use to meet the supply. It becomes in Ricardo's story, it's the price of the worst land in use. Remember we started here? This is the only land, land A. So as I expand land A, the price of land A's natural price is 10. So the natural price will remain at the center of gravity of market prices until land A is used up. Then price rises to 11, 12, 13, maybe 14, but then the supply from land B comes in. And land B's natural price is 12. So as the supply rises, the market price will fall down until it's roughly at 12. So Ricardo says, what's happened here? In the beginning, this land has virtually no rent because you sell it for some marginal amount. But when the new land comes in, the land here is producing output at $12 at a normal profit rate. But the market, the regulating price is now, 10 there and 12 here. So everyone here in the former soul land has now become good land, is making $2 per bushel of wheat that they produce on that land. And here, they're not making any rent. The landlords can give it to them for some small amount, but they can't charge any particular rent because then the people can't make a normal profit. They might leave. So in Ricardo's story, the land which is in use is the no rent land, the land which is supplying the market on the margin. Not on the margin in the sense of the small, but on the margin that it's the last land in use. The land necessary to supply expansion of demand, that's 12. And that involves no differential rent. But this land here has got a natural price of 10, which means that for every bushel they make 2. Well, Ricardo says, well, the landlord's going to say, hey, I really appreciate that you're doing so well. You're making extra profits, but guess what? This is my land. And now I know what rent I can charge. I can charge $2 per bushel that you make because that's coming not from your capital stock and profit rate equalization, but from my land. And that's the theory of rent. Differential rent is the difference between the regulating price on the land which is being used to meet expansion of supply and all other better land which has a lower cost and a lower price. And so with this, Ricardo establishes that relative prices still market prices are still regulated by prices of production, but it's the price of production of the land which is needed to meet the expansion to increasing supply. He calls it on the margin, but we mean by this the margin of cultivation, not marginal in the sense of an infinitesimal piece. This land could last like this for 15 years, so it's not a tiny piece of land. It doesn't have to be. Nothing in the theory requires that. Now, neoclassical theory, in retrospect, doesn't like that picture because this picture is the price of land goes like this, then it goes up because supply is short, then it comes back down, then it goes like this. This is a picture which is nonlinear and broken, and the neoclassical theory gets very upset with pictures that are nonlinear and have segments and all that. So they simply said, well, assume every piece of land is infinitesimal. So I use this land, then I move up to the next one, and move up to the next one, and so you draw a curve. But that curve is not necessary, nor in practice true in the theory of rent. There is a transition, but there's always, so to speak, a flat space. And in that flat space, you have exactly the old story. So from this, we can say that Ricardo can explain differential rent, which is the difference in the natural price between the better land and the land currently meeting the margin of cultivation, and yet also preserve the hypothesis that the market price is regulated by some natural price, which is the price of this regulating condition. I call it regulating conditions of production, the conditions of production which regulates the expansion of supply and hence regulate the market price. Now, this is an important point because Marx is going to make a big deal of this hypothesis by generalizing it, not just to land, but industry. What happens if you have firms with different technologies? Then you have the same principle established as generalized, and Ricardo doesn't address that. But already Ricardo makes a gigantic contribution by showing that the theory of rent does not contradict the theory of the regulation of market price by some conditions of production and hence by some natural price. Okay? That's the fastest I've ever done the theory of rent. Any questions? Okay. I will leave then for next time. I will start with the theory of trade in Ricardo, because the theory of trade is a similar question. What do I do when I have commodities between countries? Now, I've already established, and Ricardo has already argued, that relative prices are roughly equal to relative labor times, but we're talking about within a country. How is that principle modified? And just to give you fair warning, Ricardo does an utterly astonishing thing. He abandons all his old arguments and switches to a different one when it comes to the theory of trade. And that new argument, which he calls comparative cost, in which the price of internationally traded goods is not regulated by the conditions of production, but instead by the condition that demand and supply in the foreign exchange market, or in other words, the balance of trade must be zero. And Marx points out, others have pointed out, this is a most astonishing switch, because it says within a country, you have a principle that says relative prices are regulated by relative structure of production, dominated by that. And yet when you come to international trade, there is no relation at all, because a different principle comes. Trade has to be balanced. By implication, if you overthrow Ricardo's thing, you overthrow the orthodox theory of trade, which is built on Ricardo's, which says that competition doesn't matter in international trade, but every nation will achieve balanced trade. If that's not true, then you go back to Smith, who says, listen, countries who have lower costs are going to be able to win in trade, just like they win, companies with lower costs win within a country. The same principle applies. And that means that international trade depends on your cost structure. And I'm going to come back to that, something I call the China syndrome. We're going to start with that next.